Alright, so yesterday we explained a geometric series. Okay, geometric series. The difference between a series and a sequence. A sequence is a term, single term, A1, A2, A3, A4 until AN. So a sequence is a single term. We continue. Series is a summation of a sequence. Okay, summation of sequence is a series. So yesterday we have introduced a the geometric series, which is n from 1 to infinity, a r to power n. I think it's n to 0. Sometimes we do a0, a1. It does it does not really matter that much. Okay, so geometric series. Yesterday we introduced this, and the geometric series will equals a over 1 minus r if the ratio, absolute value of the ratio, is less than 1, bigger than 0, and it diverge if the ratio of the series, if the ratio of the sequence, if the ratio is bigger than or equal to 1. Okay, that makes sense, right? Because if the ratio is bigger than 1, you multiply a number and bigger and bigger, bigger and bigger, and eventually you get an infinity. Okay, if it's less than 1, well, a fraction power to infinity is going to be 0. So that's why you can, if you don't remember it, but it still can, it won't confuse you, because you can tell, okay, less than 1 is converge, bigger than 1 a diverge, and then you have to do a little bit estimation a over 1 minus r. Okay, you have to, I think this is not hard to memorize, over 1 minus r. Okay. Yesterday we also did a example. Let me see if we did an example yesterday. So today we're going to continue to look at more examples. N equals 0 to infinity, 1 over 1,000, 3 to power n. Okay, this is a geometric series. And can anyone tell me what is the ratio of this geometric series? What is the ratio of this geometric series? Okay, so this geometric series ratio equals 3. Perfect. And the ratio is bigger than 1 or less than 1? Bigger than 1, right? So now I can directly use the geometric series because of the ratio is bigger than 1. I tell, first, this is a geometric series. Second, and I got the ratio is bigger than 1, so my conclusion is therefore a diverge. Okay. In the test, if I give you a geometric series, ask if it diverge or converge, you just put first a geometric series. Second, ratio is bigger than 1, therefore it converge or it diverge. That'll be enough. Geometric series, ratio bigger than 1, that diverge. Okay. Then you got it. So next one, we want to do, I want to introduce an nth term test. What is the nth term test? So basically, I want to test if the limit n goes to infinity, an not equal 0. For example, if you have 1 plus, a moment. So the series is n from 0 to infinity, an equals a0 plus a1 plus a2 plus continue plus an. Okay, now continue with that. So now if n goes to infinity, which means they are very big, almost the last term, but n goes to infinity, and it's still not equal 0. What do you think? Does the series converge or diverge? Why is the series diverge?
Because it's still getting larger.
Yeah, it's still adding, because n is already going to infinity, and this is not going to 0. And then the thing is to get add more and more and more, it will never end. So the series will diverge. Okay, diverge. This is the nth term. So you just look at the series, the nth term. If n goes to infinity, the nth term not equal 0, you're adding something. Keep adding something. Keep adding something. Well, you never add 0. It never goes to 0. So if it goes to infinity, well, it goes to infinity. That makes sense, right? Well, my next question is, if the limit n goes to infinity, an equals 0, does this mean the series converge? If the limit of an equals 0, does this mean the an converges? Well, we know the nth term not equal 0, then the an diverge. But now, what if an equals 0? Does this necessarily, it means that the series will converge? Yes or no? Any idea? Even the nth term equals 0, the nth term equals 0. Does this mean the series converge? Well, now for sure we know this is true. If the nth term n goes to infinity, if the nth term not equal 0, even the last term is still not 0, it does not converge to 0. So you add all the things together, it will diverge for sure, because you keep adding something which is not 0, you can go to infinity. So this is true. But what about this one? If the nth term equals 0, does this mean the series converge? Yes or no? And this is not exactly true. Sometimes it's true, sometimes it's not true, okay? You cannot use the nth term equals 0, then you say the series converge. You cannot use this as a theorem, okay? This is not always true. You cannot use that to say, okay, then since the nth term equals 0, it converges. You cannot use that to make your statement, okay? The counterexample is n from 1 to infinity, 1 over n. This equals 1 plus 1/2 plus 1/3 plus 1/4 plus continue plus 1 over n plus continue. Okay? If you look at this series, the limit of the nth term, what is the limit of nth term? What's the nth term? Nth term is 1 over n, right? It's 1 over n. Well, this one equals 0. However, the series 1 from n equals 1 to infinity, 1 over n, this one diverge. Okay? However, if you add those together, it diverge. Okay? So, we're going to say why in the next section. I'm going to teach you why this one diverge. Okay, this way I can give you a little bit idea why. You can take the antiderivative from 1 to infinity, 1 over x dx. This equals ln x. From 1 to infinity, this one goes to infinity. Okay, does that make sense? Integral test. We're going to do the integral test next section, but give you a little bit hint why this one diverge. This is 1 over n. This is 1 over x. If you take the antiderivative, then this one diverge. Okay. So in the next section, we're going to introduce why this one diverge. Okay, in the example 5, let me see. Let's see. Okay, so the nth term not equal 0, this nth term test. If nth term not equal 0, it diverge. Nth term equals 0, it does not mean it converge. You cannot use that, okay? But we can use that to prove it diverge. Okay, for example, m from 1 to infinity, 4m plus 1 over 3m minus 1. Okay, so let's look at the nth term. Limit n goes to infinity, an equals limit n goes to infinity. Can anyone tell me what is the nth term of this one? What is the nth term? Yeah, Lacey, please.
I think 5 over n minus 2.
Okay, so nth term is 4m plus 1 over 3m minus 1, right? This is your nth term. Okay, basically add n equals n. You're adding a1, a2, a1, a3. This is your nth term. Okay, all right. So we're looking at the n to infinity an. So whatever this gave to you, this is your nth term. So an equals that. Now, my next question: if n goes to infinity, what is the limit of this term? Can anyone tell me?
1.
Yeah, 4 over 3. Very good. Why is this one 4 over 3? Why is this nth term 4 over 3?
You can use L'Hopital since it's infinity over infinity.
Yeah, you can use the L'Hopital's rule because the infinity over infinity, take the derivative is 4 over 3 and cancel it out, so 4 over 3. And this one, the nth term, not equal 0. So, from the nth term test, we can tell this series, okay, if the limit of an not equal 0, n equal 1 to infinity, 4n plus 1 over 3m minus 1, this one diverge. Okay? Alright. So, next example. m from 1 to infinity, m plus 10 over 10m plus 1. Alright, I'll give you 2 minutes to finish this one converge or diverge. Yeah, it's 10 times n. It's 10n. Does this one diverge or converge? Taylor?
Would this one converge?
Does this one converge? Okay, so why do you think this one converge?
Well, when we use L'Hopital's rule, we'll just get 1 over 10, which is less than 1.
So first, you compare what? You compare the ratio. Well, there's no ratio of this one. It's not a geometric series. So do you look at the nth term? Yes?
Yep.
Okay, look at the nth term. That's right. The nth term, n goes to infinity, m plus 10 over 10m plus 1. So use L'Hopital's rule. Take the is the infinity of infinity L'Hopital's rule. Then this is 1/10. The nth term test. Compare this one with what? With 1 or with 0?
With the 0?
With 0, not equal 0. So this one diverge, right? Okay. So why is this one diverge now? It's very obvious now. Because think about this. You're always at 1/10. You never end. 1/10 times infinity still giving infinity. You keep adding something at least bigger than 10. Sorry, bigger than 1/10. Because the last one is still 1/10, you continue adding more and more. You never end. Is 1/10 times infinity is infinity, at least, right? Okay. If the last term is 0, oh, I might converge because at some point it goes to 0, right? It might converge. But if in the end it never goes to 0, you don't have an end, so it diverge. Okay. All right. So next one, number 4. N from 1 to infinity, 3n to power n cubed. All right. So I would like to ask a student to help me. Matthew, could you please tell me if this one converge or diverge?
I'm guessing that it diverges because the top would be infinity, and something to the power of infinity is a lot bigger than infinity to the third power.
Okay, that makes sense. Thank you very much. If you take the n goes to infinity, limit n goes to infinity, next check the nth term test. Okay, so nth term. Look at the nth term. The n goes to infinity is going to be 3 to the power n cubed. Well, we use L'Hopital's rule because this is the infinity of the infinity form. We use L'Hopital's rule. N goes to infinity. 3n. Derivative of 3n is 3n itself multiplied by ln3. I hope you still remember that. Derivative of n cubed, 3n squared. Okay. Then it's still n goes to infinity, still infinity of infinity. We'll take a derivative again. So the limit n goes to infinity. ln3 is just a constant. I don't have to worry about that. The derivative of 3n is 3n again. You multiply by ln3. You keep the ln3 again. This is from previous one. Every time you take a derivative, it's itself. The derivative of e to the power x is e to the power x. You know that, right? But now it's 8 to the power x. It's also 8 to the power x, but times ln a. Because the ln e is 1, so we actually have a 1 here. We actually have a ln e. It's just special. Ln e is 1, so we just have it itself. But the 8 to the power x derivative is 8 to the power x multiplied by ln a. Now the derivative of 3n squared is 6n. If you continue one more time, you can see what happened. Well, this is n to infinity. It's still infinity over infinity form. Perfect. We use L'Hopital's rule again. So we got 6 and 3n, and you have ln3. You have 3 ln now, so it's ln3 to cube. This one doesn't matter. It's a constant. ln3 is just a number, but this is still infinity, so it's the infinity over 6. So this one is infinity. Well, it goes to infinity and it diverge for sure. The nth term diverge. Don't mention the whole series. Okay. So the series diverge. Okay. The next one. N equal 1, infinity, arc, tangent, n. So now, I would like to ask a student tell me what your answer is. Jasper? Is Jasper here?
Okay, so take the limit as n approaches infinity of arctangent of n, which turns out to be pi over 2.
Very good.
And since that's not equal to 0, it diverges.
Perfect. Thank you very much, Jasper. It's really good. Okay, it diverges. That makes sense, right? Well, the nth term, actually, it seems like it's really good one to use, right? But it only works for the one diverge, for the nth term which not equal 0 and it diverge. It cannot tell. It will not be able to tell you if the series converge or not. Okay, so that's what we're going to learn in the next section. We have more tests waiting for us to learn of the converge thing. Now, if we can do a lot of things, say if it diverge or not. So a lot of times when you look at the series, you check. Okay, let me check the nth term first, because the nth term is really easy to do, right? You just take the limit n goes to infinity and look at that. Look at that function. See if it goes to 0 or not. If it does not equal 0, oh, very good, it diverges. If it equals 0, we have a problem. We cannot say, oh, it converges. No. If it equals 0, we need to use something else to determine if it converges or diverges. Okay. If it equals 0, we have to continue using more tests. But if it not equal 0, it's perfect. It diverges. Okay. So I would like to also introduce some other examples of using a geometric series. Use a geometric series to write a repeat decimal. For example, 0.81 repeat. If this decimal is repeating, I put the bar on top of 0.81. What's that mean? Can anyone tell me what's the meaning of this decimal? Yeah, very good. It's 0.81, 81, 81. You continue to never end. Okay. I want to use the geometric series to write this fraction as the ratio of two integers. Okay. I want to write this one as a fraction. Basically, I want to convert this decimal into a fraction. Decimal into a fraction. Use the geometric series. How I'm going to do that? So, first, 0.81 repeat equals 0.81, 81, 81, 81. You continue. Well, this I can break it into 0.81 plus 0.0081 plus 0.000081, right? Plus 0.00000081. You continue. That makes sense, right? So the first one is 81. You add this one is a third decimal and a fourth decimal. and fifth decimal, and sixth decimal, seventh decimal, eighth decimal. So basically, you put 81, then 2 zeros, then 81 as a series. Okay. So now, can anyone tell me what's the ratio of this geometric series? This is 081. This is the A2. This is the A3. This is the A4. Right? So can anyone tell me what's the ratio?
0.01.
0.01. 1 out of 100. Both of you are right. Yes. Okay. So the ratio is the next one over the previous one. So the 0.0081 over 0.81. You both of you are right. You got 1 over 100 or 0.01. Either one is okay. So the ratio is 1 over 100. Okay. So then I can write this series. I can rewrite this series as a summation of a geometric series of 0.81 times 1 over 100 to power n from 0 to infinity. That makes sense, right? The first one is 0.81 times 1 over 100 to power 0. The second one is 0.81 times 1 over 100. So basically I put this series back into a geometric series. The summation of that, okay? Then the ratio is less than 1, and we have learned that geometric series, if the ratio is less than 1, it converges to a fraction. Can anyone tell me what that fraction is? What's the formula of that? If the ratio is less than 1, the geometric series converges to what? Can anyone tell me? A over 1 minus r. Very good. Okay. So the geometric series n equals 0 to infinity a times r to power n. This converges to a over 1 minus r if r is less than 1. Right? We have this formula, converge geometric series. Now, I would like a student help me to finish this. Bella, could you please help me to complete this? What is a, what is r, and I can finish this fraction?
Is 0.81.
0.81. One minus
R is 1 minus 1 over
1 over 100. Perfect. Yes. So can you finish that? What is the, if I convert 0.81, just 0.81 as a fraction, it's going to be what? 0.81 equals a fraction as, can you tell me that?
81 over 100.
Very good. Perfect. 81 over 100. You're doing a very good job. Yes. So what is 1 minus 1 over 100?
And 99 over
99 over 100. That's perfect. Okay. So now if I simplify this, what would I have? So keep changing flip, right? 81 over 100 multiplied by
100 over 99.
100 over 99. What cancels out?
100
100 canceled out. Oh no, what about 81 and 99?
multiplied.
Oh no, it reduce it. We have to reduce it by 9, right?
Yeah.
So 81, you got 81 over 99, but it can reduce to continue. So 81 divided by 9, you got 9. 99 divided by 9, you got 11. Perfect. So your answer is going to be 9 over 11. Okay. Thank you very much, Bella. You did a very good job. So 9 over 11 is the fraction which give you 0.818181. You can check that with your calculator. For example, if I give you a problem like this in the test, and then you get one fraction, and you can see if that's right or not. Use your fraction type. You can divide it. Say, oh, you got a 0.818181. Oh, you did it right. That makes sense, right? You can verify if use your calculator. Can verify that if this fraction equals this repeat decimal or not? Definitely this one equals 0.818181, right? Okay, so I think in the homework I did give you several questions like that and ask you to repeat that. I think I would like to give you a example to do that as an example. See if you can finish that. Another example I want you to practice by yourself. So I want you to convert 0.9. Okay, convert this repeat decimal into a ratio of a fraction. Okay, into a ratio of two integers. Convert this one into a fraction. Can you finish that? Are you done? Yes? Okay, so I would like a student to help me finish this one. How about Eric? You finish this?
Okay, so you're going to put 0.09 over 0.9.
Oh, you do the so first, how about we write the 0.9, this one into 0.9 plus 0.09 plus 0.009, right? Okay, that's it. So now you said the ratio equals
0.09 over 0.9.
0.09 over 0.9. So what the ratio is?
1/10.
1 of 10. Okay, so this one you can write as a geometric series of
0.9 times 1/10 to the n.
perfect. So then this one converges to
1.
you got what?
0.9 over 1 minus 0.01.
0.9 over 1 minus 0.1, right?
0.1.
Okay, so you got this one converges to 1. Okay, all right. So the 0.9 repeat into a fraction. You actually got 0.9 over 0.9. We just got 1. Okay, so you got the ratio is 1 over 1. Well, 0.9 over 0.9. You got the answer is 1. Does that make sense to you? It does not. or yes or no. You have something is 0.99999. You continue, keeps going, you never end. It actually, you consider that also equals 1 because it never ends. If it ends at some point, it's not 1. But it never ends. It is so close to 1. They are not have actually. They don't actually have any difference. Okay, if you put a difference, the difference is going to be almost 0 because it's going to be 0.000. Have infinitely many zeros, and which is 0. So that's why this one equals 1. That's true. Okay. All right. So I would like to give you more exercise about the geometric series, and also the I think we did introduce another series, which is alternating series or telescope series. I think I want to do that example first. Okay. N from 1 to infinity, 1 over n times n plus 1. This one. I want to find out the this one converge. Verify this one converge. Okay. So I have not introduced any definition, any properties about whether it converges or not, except the geometric series. But this is not a geometric series. How do we verify this converges, or how do I know what this is? Okay. So first, if I ask you to find out this series, what do you think you want to do? Can you tell me? I want to say, what is the series converge to? So what's the first step you would like to do?
Look at the first few terms.
Look at the first few terms, which is good. We can do that. N equals 1, very good. Yeah, we can do that. N equals 1, so it's 1 times 2. No, I cannot do that, right? I have to write down that equals. So n times n plus 1. The first few terms will be n 1 times 2 plus 2 times 3 plus 3 times 4 plus 4 times 5. Continue. So then what do you think? Huh?
Can we cancel the 2's in the bottom and the 3's in the bottom?
How do we cancel that? So whenever you say something like, oh, okay, someone? Lacey? Someone? Anyone? Okay. So whenever you say something like this, is there anything you think about partial fractions? Have you ever considered about partial fractions? Yes? So if I do partial fractions, this will equals n from 1 to infinity. I want to put this one as 2 different fractions. It's going to be is n over a, but this is I think it's a pretty simple one for you to estimate, and 1 over n plus 1, right? Because the fraction is 1, you can do that, n over n plus 1. You can partial fraction is a over n plus b over n plus 1. We can do a quick estimation. Okay, so this is n plus 1, this is 1. They just have a difference of 1. What do you think I have put in the middle? What do I put in the middle? Plus or minus?
Minus.
Minus, very good, okay. For example, you can check that 2 times 3, which is 1 over 6, which is half minus 1/3. You can use that partial fraction, find a equals 1, b equals -1. For sure, this is a pretty simple one. But since this is 1 over n times n plus 1, I don't repeat that again. You can do that, it's easy one, you can do that. You got n equals a times n plus 1 plus b times n. Name n equals 0. Name n equals, let n equals -1. Find a, find b. That's okay. Okay, it doesn't take much time to do that. Since this is an easy one, then we just can directly say this is 1 over n minus 1 over n plus 1. Because combine those two is n plus 1 subtract n, you just have a difference of 1, which is the numerator. Alright, so now I can write this one as a fraction, 1 over n, which is, first term is 1 minus second term 1/2 plus, this is the first one, n equals 1. N equals 1. So when n equals 2, can anyone help me what n equals 2 when I do? So n equals 2, what I got?
1/2 minus 1/3.
Perfect. Okay. So I think continue, you are going to get 1/3 minus 1/4. We'll continue. I remember that one of the students, I don't remember, who just said that it was cancel the 2 and the 3s and all of those. Okay. So this is how you cancel it. You get a good idea. I think you probably see this one where you have idea of this one, but this is the right way how you can cancel it out. Then you have -1/2, +1/2, -3rd, +3rd, -4th, +4th. So you cancel all of the middle ones. So last one is 1 minus 1 over n plus 1. If n goes to infinity, this one goes to 0. N goes to infinity, so just 1. So n goes to infinity, 1 over n plus 1 equals 0. Because 1 over infinity, right? 0. So it's 1. That makes sense, right? Alright, so how about I give you another one, see if you can finish this one. Example. N from 1 to infinity, 1 over n plus 2. So can you finish this one? Okay, are you done? Okay. Can anyone tell me what your answer is?
1/2.
1/2. Okay, very good, Jasper. How did you get 1/2?
Okay, so when you do partial fractions,
Mm-hmm.
you get 1 over n times n plus 2 equals a over n plus b over n plus 2. And then if you solve that, you get a equals 1/2 and b equals negative 1/2.
Okay. So can you put it 1/2 in front of that?
Yep.
Okay, because you got a equals 1/2, b equals 1/2, you can put the 1/2 in front, you got 1 minus negative 1. The reason I do that, then we can say this one will equals, the first term is 1 over 1 minus 1 over 3 plus, second one is 1 over half minus 1/4. Third one is 1 over 3 minus 1 over 5. Okay, you continue. The first one will cancel with the third one, 1/3. You still have 1/3 in here to be able to cancel out. That makes sense, right? You have, because a equals 1/2, you can do partial fraction 1/2 is out. You just write down n equals 1, plug in, and then everything will be canceled for sure. And then, wait, is it 1/2, 1/4? Because it seems like 1/2 will not be canceled. No, it will have 1/2. The first one, the next one is going to be 1/4 minus 1 over 6. So 1/4 cancel with this one. All of them will cancel out except the first one plus 1/2. And you have minus the last term, then plus 2 will not be cancelled out. So if I write 3 terms, the last term, which is 1n plus 2, will not be cancelled out. And also n plus this one, first one, this one, and 1/3 cancelled out. So 1 over n minus 1 will not be cancelled out either. Okay, so if you got this, the reason I can know which one not cancelled, this is A1, this is A2, right? 1 over n, and then this is your last term, 1 over n plus 2. This one will not be cancelled, this one will not be cancelled. Even you continue, you think about this, the last term is 1 plus n plus 2. This is 1 over n plus 1. So this will not be cancelled out. And if n goes to infinity, your answer will be 1/2. This 2 goes to 0 times 1 plus 1/2 will be 3/2 and equals 3 over 4. Does that make sense? Yes? Is that what you got, everyone? Wait.
This one, I don't know if I just put it in wrong, but it told me it was wrong. But I checked my notes and I checked on a calculator and everything, and it gave me the same answer.
And then your, wait, this is homework what?
This is quiz.
Chapter 7, sir?
Yeah.
You have three tries, right?
Yeah.
You try the third one?